Hi, this is Victor and welcome back to my math tutoring channel. In this video, we will find the general term of the following series, which is 3 over 5, 3 over 4, 12 over 11, 12 over 7, and 48 over 17. Then, we will determine if this series converge or diverge. Looking at that series, it's not easy. It's one of the difficult problems because the second term, I have 3 over 5 in the first term and 3 over 4 on the second term. And then the third term numerator is 12 and the fourth term the numerator is 12. So I don't see a relationship. How can I go from 3 to 3 and then from 3 to 12 and 12 to 12 and 12 to 48? But if I take the second term here, 3 over 4, and the fourth term, 12 over 7, and I multiply 2 in the numerator and in the denominator. How did I come to that conclusion? It's by practice. Practice make you strong. Practice like you can see stuff that you cannot see. So now I will rewrite this series as 3 over 5 and then 3 times 2 over 4 times 2. It's the same thing. And 12 over 11, and then 12 times 2 divided by 7 times 2, and then 48 over 17. So the series becomes 3 over 5, 6 over 8, 12 over 11, 24 over 17, and 24 over 14, sorry. Because 7 times 2 is 14. And 48 divided by 17. Now if I look at that series, which is exactly the series that I start with, 6 over 8 is equal to 3 over 4, and 24 over 14 is equal to 12 over 7. So I can see that I'm doubling up the numerator. It used to be 3, it becomes 3 times 2, 6, 6 times 2, 12, 12 times 2, 24, and 24 times 2 is 48. And in the denominator, I'm adding 3 all the times. 5 plus 3 is 8, 8 plus 3 is 11, 11 plus 3 is 14, and 14 plus 3 is 17. So if the series is, if n is even, an become, if n is the number of terms, like for term number 1 n is equal to 1, for term number 2 n is equal to 2. If n is even, the series becomes 3 times 2 to the power n minus 2 divided by 3n plus 2 divided by 2. This is an equal. So if n is even, which is, in that case n is equal to 2, we start with 2 minus 2 is 0, 2 to the power is 0 is 1, yeah, and 3 times 1 is 3. So now I'm having this term. This is how I get this 3 here. And then in the denominator, 3 times 2 is 6, plus 2 is 8, divided by 2 is 4, and this is my 4 here. If I take the fourth number, n equal to 4, 4 minus 2 is 2, 2 to the power of 2 is 4, 4 times 3 is 12, and this is how I get my 12. And in the denominator, 3 times 4 is 12, 12 plus 2 is 14, 14 divided by 2 is 7, and this is how I got my 7. I will find you the 1, 2, 3, 4, 5, the sixth term later on when we do the series. And if n is odd, a of n is equal 3 times 2 n minus 1 here divided by 3n plus 2. So if n is equal to 1, 1 minus 1 is 0, 2 to the power is 0 if is 1. And then here I have my 3 times 1 is 3, and this is where I got this 3 here. And if n is equal 1, 3 times 1 in the denominator is 3 plus 2 is 5, and this is how I got my 5. If n is equal to 3, I'm trying to get this, the third number. 3 minus 2 is 1. 3 minus 1 is 2. 2 to the power of 2 is 4. 4 times 3 is 12, and this is this 12. And 3 times 2 is 6 plus 2, 7, 8. 3 times 3 is 9 plus 2 is 11. The third term, we said 3 times 3 is 9 plus 2 is 11, and we're gonna continue that series, and you're gonna see that it is right. So that is the general term of my series. So if I want to find 1, 2, 3, 4, 5, the sixth term, yeah, because here I have 5, the sixth term become the 6 is even, so I will take that series because this number 6 is even. 6 minus 2 is 4. 2 to the power of 4 is 2 times 2 is 4 times 2 is 8 times 2 is 8 times 16. And 3 times 16 is 48. So this become 48. The sixth term become 48 here. And the denominator is 3 times 6 is 18. 18 plus 2 is 20. Divided by 2 is 10. If I multiply that by 2, if I follow the same logic that I brought this 6 over 8 and this 24 over 14, if I multiply it by 2, 48 times 2 is equal 96 times 2 times 2, which equal 96 over 20. So 48, we doubled the 48 to become 96, and we doubled the 17, we add 3 to the 17, it become 20. If you continue like that, and you're gonna see that you're gonna find all the element of that series. So the general term, if n is odd, it is this, and if n is even, it is that. Now let's see if the series converge or diverge. Let's write it down here. Conversion test. If either if an either for the even or the odd number, if it diverges, that means the series diverges, because one of the term is divergent, it diverges. So let's take if n is odd, like because we started with n equal to 1, an is equal 3 times 2 n minus 1 divided by 3n plus 2. And let's apply the ratio test here to see if it diverges. Apply ratio test. The ratio test is the limit when n goes to infinity, the absolute value of an plus 1 divided by an. So I can take the even or the odd. I took the odd, but you can take the even. Actually, both of them diverge. So an plus 1, all what I have to do is replace the n here by n plus 1. So an become an plus 1. Let's do it right. An plus 1 is equal 3 times 2 to the power n plus 1 minus 1, because I replaced the n by n plus 1, divided by 3 n plus 1 plus 2. So that series become an plus 1 is equal 3 times 2 n plus 1 minus 1 is 2 to the power of n, divided by 3 times 3n is 3n, 3 times 1 is 3 plus 2 is 5. So this is the an plus 1, and I know my an is equal 3 2 to the power n minus 1 divided by 3n plus 2. And now let's find the limit of the ratio. So the limit when n goes to infinity, an plus 1, I can write it 3 times 2 to the power of n divided by 3n plus 5. Instead of putting divided by, I can write the divided by like this. 3 times 2 to the power n minus 1, 3n plus 2. Absolute value. And we know I can replace the division by multiplication, but I have to reverse the second term. So it is the limit when n goes to infinity of 3 times 2 to the power n, 3n plus 5, multiplied by 3n plus 2, divided by 3 times 2 to the power n times 2 to the power minus 1. Because the law of exponential, this is 2 to the power n minus 1. 2 to the power of n times 2 to the power minus 1 is 2 to the power n minus 1. And here I can simplify 3n here and 3n here. I can simplify 3 from here and 3 from here. Wait a minute, there is a plus. I cannot simplify anything, I'm sorry. If it has all that, it was multiplication, I can simplify. Okay, let's do it into another way. Here I can simply, because in that denominator it's always times, times, times. In this numerator it's always 3 times 2 to the power of n. I can simplify the n here, and then I can simplify the 2n that is here. And it becomes the limit when n goes to infinity of 3n plus 2 divided by 3n plus 5. And here I have 2 to the power minus 1. I can bring it to the numerator, it becomes 2. And this is the absolute value. So this is equal limit when n goes to infinity of 6n plus 4 divided by 3n plus 5. Again, absolute value. It is equal. I can factor out n in that limit. So I can put limit when n goes to infinity of n times 6 plus 4 divided by n. Because if I multiply n times 6 is 6n, and n times 4 is 4n divided by n is 4. Divided, and I factor out n here, and it become here 3 plus 5 divided by n. So here n and I can simplify it, and when n goes to infinity, this would go to 0. 4 divided by infinity is equal to 0, and 5 divided by infinity is equal to 0. So I would have it's equal 6 divided by 3, which is equal 2. And since the limit is 2, since 2 is greater than 1, the ratio test indicates that this series diverges. Ratio test indicate that the series diverges. So if you like my video, please subscribe to my channel. That would help me tremendously. And if you push the like button, I would really appreciate it. Thank you for listening.